There are two pictures that everyone at this conference is required to show, and this is one of them. I'll show the other also. What people haven't mentioned is this one came from the high school yearbook here in Flagstaff in 1905. No, VM wasn't a high school student, he was 30 years old, but he was on the school board. In fact, he was one of the founders of the high school. When he came here, Flagstaff had 800 people, so there were a lot of things to establish. He came here in August of 2001, 2 months after completing his BA in Mechanics and Astronomy at Indiana University, because his professor, Wilbur Cogsall, had persuaded Percival Lowell to hire him temporarily. As you just heard, he arrived at age 25, and he stayed 53 years. After retirement, he lived 15 more years in Flagstaff before dying 3 days before he would have turned 94. I'll discuss his life in Flagstaff, which I divide into 5 parts, and his research on the night sky, the aurora, planets, comets, stellar radial velocities, variable stars, and interstellar gas and dust. We've heard from others about his early life and about his work on globular clusters and galaxies. Great achievements under Lowell. This was the best time. In his early years, he was not his own man, and this suited him perfectly, as he had few original ideas and was happy to take direction from his employer. As John Hall wrote in an obituary in Sky and Telescope, Slipher and Lowell had complementary temperaments. The latter was brilliant, enthusiastic, and a driving personality. Slipher, on the other hand, was deliberate, fastidious, patient, and showed a high order of technical knowledge. Slipher knew what he wanted, Lowell knew what he wanted, and Slipher provided it. Here, on the left is the other picture that everyone has to show at this conference. What people don't usually mention is that it was taken at Mount Wilson.
What?
I believe so.
Really?
No. I thought it was. Lowell, of course, was primarily interested in the solar system with special emphasis on Mars. He wanted Slipher to find chlorophyll, as well as oxygen and water there. And as we've heard, he asked Slipher to obtain a spectrogram of a spiral nebula because he thought of it as a newly forming solar system. However, he allowed Slipher to spend some of his time on his own pursuits, and Slipher was interested in the then fashionable fields of measuring stellar radial velocities and discovering spectroscopic binary stars. His first publication in the Astronomical Journal in 1902 was a report of measurements of the variable velocity of Zeta Herculis with the new spectrograph. Note that he compares his average radial velocity of minus 74.4 with the minus 74.6 reported earlier by Lowell Observatory's W.W. Campbell, who was swiftly becoming recognized as the world's leading astronomical spectroscopist. Incidentally, as a teacher, I would take points off for not specifying units. He just gives numbers, no units. And it's especially bad because Slipher sometimes quoted velocities in miles per second, some of his tables. I had to go to Campbell's article to find that the velocities were in kilometers, which at the time was the standard abbreviation for kilometers per second. Volume 1 of the Lowell Observatory Bulletin, dating from 1903 to 1911, shows that Slipher was already an important member of the Lowell team. The volume contains 62 articles, 13 of them by Slipher alone and 1 co-authored by him. The 38 by Lowell, some of them including spectroscopic observations by Slipher, and 10 by the other members of the staff. All of Slipher's publications in this early volume present spectroscopic observations of stars, including spectroscopic binary stars, standard velocity stars, and we just heard how useful those were, and stars of variable radial velocity, of the moon and planets, and of Halley's Comet. Incidentally, Halley's Comet data were used in 1991 by a couple of Lowell astronomers who compared their observations of the spectrum of the comet in 1985-86 with Slipher's from 1910. And they listed him as a co-author 22 years after his death. So that extended his publication stream quite a long time. He also began an extensive study of the Crab Nebula, which he never published, although Bill Hoyt wrote an unpublished manuscript about that, and it may be published soon. Among his most important discoveries in this period were 2 involving the interstellar medium. In 1909, he published an account of the selective absorption of light in space, proof that there were calcium ions in the interstellar medium between the Sun and a number of stars in Scorpius, Orion, Ophiuchus, and Perseus. In each case, the sharp, weak calcium lines remained stationary, while lines from the binary star shifted back and forth. This confirmed a hypothesis made earlier by Johannes Hartmann of Potsdam, who had found stationary calcium and sodium lines in Alpha Persei in 1901, and calcium again in a single-line spectroscopic binary, Delta Orionis, in 1904. Slipher found the first reflection nebula, evidence of what we now call interstellar dust, in 1912. He noted that he found the spectrum of the clouds surrounding Merope, a star in the Pleiades, to be identical to that of the star. So this could be explained by assuming that, quote, the nebula is disintegrated matter, similar to what we know in the solar system, in the rings of Saturn, comets, etc., and it shines by reflected light, unquote. However, he ended this paper, published in December 1912, while he was in the midst of his observations measuring the huge velocity of approach of the Andromeda Nebula, with this quote, which someone scooped me by reading yesterday. The observation of the nebula in the Pleiades has suggested to me that the Andromeda Nebula and similar spiral nebulae might consist of a central star enveloped and beclouded by fragmentary and disintegrated matter, which shines by light supplied by the central sun. This conception is in keeping with spectrograms of the Andromeda Nebula made here and with Boland's value for its parallax. Well, as we have heard, he changed his mind within a couple of years. Also of considerable importance was his work on the planets. As early as 1903, he showed that his spectrograph could measure the rotation period of Mars. He obtained a period of 25 hours, 35 minutes, or, quote, just 1 hour longer than the true period. Mars, of course, you can see the markings in time. At the time when many thought the rotation period of Venus was about 24 hours, he showed that it was far longer than that. In fact, the rotation was too slow to measure. He stated flatly that if it were rotating, the period had to be much longer than 10 days. The following year, he published spectrograms of Uranus and Neptune and compared them with purely solar radiation from the moon. By 1906, he had added Jupiter and Saturn. After experimenting with new sensitizing dyes on his plates, he found a combination which allowed him to be the first to extend his spectrograms past 7,000 angstroms into the red. So in 1909, he provided completely new analyses of the spectra of all 4 major planets. He found new absorption bands in these planets, stronger bands in the more distant planets, and he failed to find evidence of oxygen in any of them. He was able to show that his spectrograph could detect the rotation of Uranus. He tried in 1903 without success. 6 years later, Lowell pointed out to him the line of sight component of the rotational motion had increased, and he tried again. They assumed that the satellites marked the equatorial plane, so they could estimate that. By 1911, he obtained 7 good spectrograms, and his results were published the following year. Both he and Lowell measured the plates without knowing their orientation. His final result was a rotation period of 10 hours, 50 minutes, not particularly good by today's standards, 17 hours, 14 minutes, but it was the first to be measured. It was during this period that Wilbur Coxall, who had taught VM astronomy at Indiana University, wrote him and suggested that the university might award him a PhD for research he had done at Lowell. VM was enthusiastic and said what he considered, quote, by far my best work, unquote, a published paper on the spectrum of Mars to serve as his thesis. So that paper is wrong. It says he found water in it. But he almost lost the degree when Lowell declined to allow him to go to Bloomington to defend it in 1908. Coxall suggested that Lowell was offended that Slipher was even asked to defend it. Lowell thought that the degree should simply be conferred. Slipher did receive the degree a year later, with all the residency course requirements waived. By the time of Lowell's death, one day after Slipher's 41st birthday, VM had begun examining the night sky with heroic exposures, discovering what he called the permanent aurora, a yellowish line at 5577, known from aurorae, present in all of his spectrograms. He had also added observations of nebulae and interpretations involving the interstellar medium to his published work. And of course, he also observed what we now call galaxies, but you've heard more than enough about that. Probably the most important date in his life, the major transition, was the unexpected death of Lowell on 12th November 1916. Just 8 years after Lowell's marriage, and 1 year after he had appointed VM assistant director and designated successor. It was a disaster for his observatory and its staff. For the next decade, successive trustees fought legal battles with Lowell's widow over the estate. She received half the income, and it was a struggle to keep the observatory open. As acting director, VM had to be extremely parsimonious, and it was a difficult time. Slipher had married in 1904, and his children were 9 and 5 when Lowell died. He was justifiably concerned with supporting his family. If she had won, the observatory would have closed. The daily ration of milk from the observatory cow, Venus, was helpful, but not sufficient. Slipher started buying rental properties and eventually bought a number of ranches. He owned a furniture store at one time. He also took part in civic activities, serving, as I mentioned, as president of the school board when his children were in school, and joining with others to found the Museum of Northern Arizona. He served as chairman of the board of Flagstaff's premier hotel, Monte Vista, still there to this day. It was founded by public subscription, and including a major donation from author Zane Grey. It was built by the city, and owned by the city for the first few years, built in 1927. And Slipher remained chairman of the board even after it was sold to a private owner. Meanwhile, the Slifers raised their family on Mars Hill. I don't know whether you can see that there's an infant in Slipher's arms, but that's his son. And it's with his wife and mother-in-law. Despite these distractions, Slipher continued to be astronomically productive. It was during this period that he published observations of the spectra of both galactic and extragalactic nebulae and measured the rotation speeds of planets. He made his only forays into solar astronomy, leading eclipse expeditions to Kansas in 1918 and Baja California 5 years later to photograph the spectrum of the solar corona. And he continued the Lowell-inspired search for water and oxygen on Mars. He also published his first investigations of the spectra of lightning, the aurora, and the night sky. Third part of his life in Flagstaff were the last productive years, 1926 to 33. Slipher was appointed director, as opposed to acting director, of the Lowell Observatory in 1926, after the final settling of the Lowell estate. Mrs. Lowell continued to receive half the income until her death in 1954. Correspondence between VM and trustee Roger Lowell Putnam shows that the observatory was frequently in the red, and paychecks were not always on time. The trustee often helped with an extra check for $500 or $1,000, and even got his mother to pay the salary so that the observatory could have a secretary. The observatory staff lost heavily when Flagstaff's only bank failed in 1932. During this period, Slipher published his most extensive work on the night sky, the zodiacal light, and the aurora, and he published additional spectroscopic observations of Venus, Mars, and comets. Every time Kenneth Meese of Eastman Kodak came up with an emulsion that was sensitive a little farther out into the infrared, Slipher used it to extend his planetary observations. One of his night sky spectrograms involved exposures totaling 147 hours. I'd like to know whether that's the record. No, it's not. The whole deep field is more than that. He also continued his observations of nebulae and studies of the interstellar medium. His most famous work during this period was, again, an effort to carry on the work of his master. Lowell had spent years computing orbits with much of the tedious calculation done by assistants, especially Elizabeth Williams, and attempting to make a prediction that would lead to the discovery of a ninth planet that would account for the perturbations of Neptune. In his highly mathematical 1915 book, which this is the cover, I don't know whether you can see it, Memoir on a Trans-Neptunian Planet, he called it Planet X. He employed as many as 5 computers in Flagstaff and Boston, and had hired 3 successive Lawrence Fellows to observe in Flagstaff, searching for the planet. But he died without knowing whether it existed. In his book, he had suggested 2 regions of the ecliptic in opposite directions where the planet might be found. In 1927, glass discs for 13-inch refractor became available, and V.M. Slipher suggested to the trustee that they be purchased and made into a telescope to resume the search for planet X. Trustee Guy Lowell personally purchased the discs and planned to have the telescope made, but he died later that year. At this point, another member of the Lowell family, Percival's brother, Lawrence Lowell, then president of Harvard, stepped in and funded the building of the telescope. It arrived in Flagstaff in 1929. You can see it today, it's often on display, and was erected on a mounting built by the observatory's longtime instrument maker, Stanley Sykes. Designed from the start for the planet search, the Lawrence Lowell telescope produced highly defined star images over 14 by 17-inch plates. It could record 50,000 to 500,000 stars in a 1-hour exposure, depending on where in the sky. The plan was to photograph every field along the ecliptic, starting with the area suggested by Percival Lowell, to repeat a few days later, and then to blink the plates in order to find objects that moved. Blinking the plates was incredibly tedious work. Slipher hired 23-year-old high school graduate Clyde Tombaugh to do it, and the rest is history. It is to Slipher's credit that Pluto is universally recognized as having been discovered by young Tombaugh. It had been found at one of several other major observatories at that time. The director would have claimed the credit. This is characteristic of Slipher's modesty. It is to Slipher's discredit that, knowing that the Lowell Observatory lacked the expertise to compute the orbit of the newly discovered planet, he delayed announcing the positions so that his former teacher, John Miller of Royal Observatory, could come to Flagstaff and lead the computation of the first orbit. This infuriated many in the astronomical community, such as the ACE orbit computers at Berkeley, who could have produced an orbit much faster. The doldrums. The year 1933, when he turned 58, was essentially the last year that Slipher published his own original research. His 5-page article on spectra of the night sky, the zodiacal light, the aurora, and the cosmic radiations of the sky appeared in the Transactions of the American Geophysical Union and was reprinted in the Journal of the Royal Astronomical Society of Canada. It reports on many years of work, including the use of a newly designed spectrograph to photograph the spectra of 5 regions of the sky at once. He designed and built many spectrographs over the years. That year he gave the George Darwin lecture to the Royal Astronomical Society after accepting the RAS gold medal. The lecture was on spectroscopic studies of the planets and summed up his work, mostly completed long before. After that, the Lowell Observatory slowly declined. For a great many years, 3 men, V.M., C.L. Lamplin, and V.M.'s younger brother, E.C. Slipher, dominated the observatory. All of them were addressed by everyone by their first 2 initials. No one had called him Vesto. Occasionally, a younger man, such as Henry Gickless in 1931, would be hired to a subordinate position, but the 3 senior astronomers jealously guarded the telescopes. All had been seriously wounded by the criticism from other astronomers, especially like observatory directors Campbell and Wright, of work done at the Lowell Observatory. These eminent astronomers had developed an intense distaste for Percival Lowell and anything associated with it. Work coming from Lowell's observatory was automatically suspect. V.M. had gotten into an exchange of criticism, published exchange, with Campbell over his claim to have detected water on Mars in 1909, and after losing this battle, he became even more reticent than he had been. He was very careful to check his work many times and to get repeated observations before going public. He devoted more and more time to his business affairs and less to research. Meanwhile, his brother E.C. spent much of his time on politics, spending half the year in Arizona as a state senator for some years. And Lamplin puttered around without completing much of anything. V.M. published his last observatory report in 1933, covering the years 1930 to 32. The next to appear from Lowell Observatory was for the years 1952 to 54. Although signed by V.M., it was probably written by Albert G. Wilson, who was assistant director at that time. The most significant papers with Slipher's name on them after 1933 were of a totally different character from his other work. There were 6 of them published in Nature and the Physical Review, and they contained astrophysical observations and theory far beyond Slipher's abilities. They were written by Arthur Adell, who'd been hired in 1933 by the trustee over the opposition of the senior astronomers. Adell was to work at his alma mater, the University of Michigan, and do infrared studies that would relate Slipher's spectra to conditions on the planets. Adell built a 22.5-meter long tube, high-pressure cell, and put up to 40 atmospheres of carbon dioxide in it. Later, he filled his tube with ammonia and methane. He was able to duplicate some of the spectra that Wilson astronomers had observed in Venus in 1932, and that VM had observed in Jupiter many years earlier. He did this entirely by himself in Ann Arbor for $1,000 per year, which even in 1933 was not very much. Adele used Slipher's published data from 20 years earlier, but got nothing new from Slipher. Nevertheless, he put Slipher's name on the papers as co-author. In 1987, Adele told Robert Smith in an oral history interview, "I had to do that, and neither he nor Lamplin nor E.C. Slipher, none of them really knew what I was doing, had a real understanding of it. They didn't know anything about infrared spectroscopy." Adele even said they didn't know anything about spectroscopy. They really didn't know anything about this work that I was doing or the work I did in Ann Arbor. When Adele finally was appointed to a lowly position in Flagstaff, VM treated him very badly. And when Adele showed that the carbon dioxide bands in the spectrum of Venus could be photographed with a 24-inch refractor, and thus could have been discovered by Slipher before they were found by Adams and Donald Wilson, he was barred from the telescopes. Slipher resisted applying for grants, couldn't be bothered with the complications of payroll, Social Security, all these new things. So Henry Gickless was appointed secretary in 1953 and took over all the business affairs from then on. Trustee Roger Putnam pushed for grants, and the first from the Weather Bureau was obtained in 1948 and included funds to measure the variation in the solar constant, as well as meteorology of planetary atmospheres. Later, this project was taken over by the Air Force. The appointment of Harold Johnson in July 1948, initially to work on the Weather Bureau project, was a turning point. Although very difficult to get along with and constantly complaining, Johnson was a competent, energetic young scientist, and he accounted for nearly all the observatory's publications in the early 1950s. He quit and went to Yerkes after 1 year, but came back in August of '52. Slipher's last scientific publication was a brief abstract in 1939, announcing that he had reobserved Hubble's variable nebula and found that its spectrum had not changed since his observations more than 20 years earlier. He also wrote an occasional letter asserting his priority in something done long before. After Lamplin died in December 1951, Trustee Roger Putnam finally stepped in to make some changes. On the advice of John Duncan, he selected 33-year-old Albert G. Wilson, who had been directing the National Geographic Palomar Sky Survey since completing his PhD in mathematics at Caltech. It seemed that the primary criterion for the appointment was that Wilson was acceptable to the Slipher brothers. Wilson came as assistant director in 1953 and took over as director on VM's 79th birthday, 11 November 1954, when the old man finally retired. Wilson's directorship was short and unhappy. After rebellion from the younger astronomers, especially Harold Johnson and Henry Gickless, and the breakup of his marriage, he left in January of '57 and returned to California in a career in industry. Incidentally, Wilson died less than 3 weeks ago, on the 27th of August. He lived 10 miles from me, and I visited him a few times, talking to him about this place. Slipher remained in Flagstaff, although he moved off Mars Hill in one of his houses. His wife Emma died in 1961. Frances Wilson, the ex-wife of Slipher's successor, returned to Flagstaff and became Slipher's private secretary and companion, according to Henry Gickless. Slipher died on the 8th of November 1969, 3 days before he would have turned 94. His will stated that, quote, "During the latter years of my lifetime, Frances M. Wilson has devoted herself to my business affairs, and it is my desire for my estate to make provision for her." He left her $3,000 per year for life, which was a lot of money back then, and he made her executrix of his estate. Aside from the endowment to support her, he left his wealth to the VM Slipher Trust, with a bank as trustee, and Arthur Adele, of all people, as advisory trustee. A portion of the income was to provide scholarships for worthy students pursuing scientific studies at Arizona's 3 public universities, with Adele choosing the people to get the scholarships. And after that, half the income went to the National Academy of Sciences for astronomy. There was a lot of property, including ranches and cattle. Aside from his work on galaxies, which most of this meeting has been devoted to, he spectroscopically discovered new lines in the aurora in the night sky, discovered the permanent aurora, confirmed the absence of chlorophyll in the Martian atmosphere, found that Venus was a very slow rotator, confirmed the rotation period of Mars, refined the periods of Jupiter and Saturn, made the first determination of the rotation period of Uranus, found new lines and bands in planetary atmospheres, comets, and the Sun, confirmed that the stationary lines of calcium are due to interstellar clouds, and discovered interstellar dust. So there's a lot more to VM than galaxies. Today's Slipher is probably underrated, at least outside of Flagstaff. I gave a talk at a Historical Astronomy Division meeting 6 years ago titled, "Why Does VM Slipher Get So Little Respect?" My current conclusion is that the most important reasons are, one, he needed Lowell to guide him, and Lowell's early death left him unprepared to face the future. Although a very skilled spectroscopist, he lacked the imagination to innovate. Two, the early criticism of Lowell and everyone around him made Slipher and his colleagues super cautious about making any claims. They hesitated to publish until they were absolutely sure they were right. Fortunately, this happened a few times at the end. He was sure enough to go ahead and publish. His brother AC would never have published it at all had the trustee not forced him to. The result was a fine atlas of thousands of photographs of Mars. The third member of the staff, C.O. Lamplin, you can see the poster over there about him, he did pioneering work in radiometry, but he hardly ever published. He always wanted more observations, to be sure. All three of them stayed too long, at least in part because there were no pensions until they were introduced by VM's successor, Wilson, in the 1950s. And three, and this one I did not say 6 years ago, but I'm adding it now, he was not properly credited by Hubble for the Doppler shifts of galaxies that Hubble used so successfully in the 1929 paper, which is the most quoted paper. Hubble did give him plenty of credit in later papers. Slipher's brief obituary in physics today, that's it in its entirety, is underwhelming. It mentions only Pluto among his accomplishments. Although it does mention a few of his medals, some of them received before Pluto, without saying what he got them for. I want to thank the wonderful people at the Lowell Archives who provided me with access to everything and with lots of pictures, tremendous amount of help. Thank you.
We have a couple minutes for questions.
I just want to thank you, Joe, for giving us a more rounded picture of VM, because last night we were talking over drinks and thinking this person was a real saint. He still might have been a saint, but at least he was human as well.
So I wouldn't call it a saint. I can't think of anyone I would at the moment. Yes.
I just have a question about his name, Slipher. Was that an anglicized name of Scottish, German, Polish origin? Where did the family come from?
I've read that, but I don't remember it.
We're from Rhineland, Germany originally.
From Germany.
Okay, well,
It's
there's
anglicized.
Yeah.
But everyone always called him VM.
Even his wife?
I don't know what it is. Probably different things at different times.
Yeah.
Possibly one reason, I know this is slightly silly, but why not? There was a telegram that was sent from Lowell to Lick in 1909 announcing the presence of water vapor in the Martian atmosphere by Slipher. So, many times to avoid confusion.
Well, W. Campbell was a very intimidating person, and
No, that was the telex operator, not Campbell.
okay, and he became extremely influential in American astronomy, and Slipher was, I'm sure, was afraid of him. Yes.
Yeah, I just want to reiterate the point I made this morning, though. I think if he published his papers in somewhere else that was more continuously available to professionals, I'm sure it would remain in people's minds more. Whereas the fact he had this art of picking somewhere that was about to go out of business.
With the exception of that one paper in the Journal of the American Philosophical Society, almost everything was in Lowell Observatory bulletins, and they were exchanged with all the other observatories. However, I cannot state that people at places like Lick and Mount Wilson actually opened those Lowell Observatory bulletins when they came. They may have.
Correct.
Last question.
Thank you very much. I was struck by the very first slide you showed that the You know, the cruel irony is that Slipher himself was so conscientious about citing everybody else and comparing his work to what had gone before. And you know, the 1970 paper where he lists every other possible measurement on what has ever been done, and yet he himself was treated so badly that way. It's really striking. Just to add to John Peacock's thing, I think there is a sort of sociological thing as well, though. It really does seem that if a scientist is overlooked at the time, then they get overlooked forever. That's for sure. And I think that's because a lot of people, certainly in the old days when they're writing about it, they forget, as Stephen Weinberg pointed out, they forget to look at primary sources, you know. So if you miss the boat the first time, well then the other people who are then writing later, they simply quote other people and then gets lost in the mist sometimes.
Do I have time? Yeah, ask Owen. Hasn't there been some effort to give Thomas Harriot credit for observing the Galilean satellites before Galileo, even though he didn't even publish it all?
I hope not.
Comes up in conversations. All right, well, thank Joe once more, please.